My name is Will Foster. I'm originally from North Carolina. I've lived in Ireland for about 2 years, and before that I was in Czech Republic for a few years. I'm going to be speaking about a new automation and provisioning project that we've created and really kind of how we've fostered DevOps within our organization, within engineering.
All right. I did not endorse that video, by the way. That is not me. That is a stunt double. So, thanks for coming to my talk, folks. My name is Will Foster. I am a systems engineer at Red Hat. I've been there about 10 years or so. Various roles within the company. I started out on the sysadmin kind of production operations side, where we managed all of the facing infrastructure for Red Hat, for RHN, all the backend storage, databases, that sort of stuff. Around 2012, I moved over to the engineering side of the house and started to work on OpenStack. Who here, just to show of hands, has heard of OpenStack or is familiar? Awesome, almost everybody. So I worked on that for a few years, and then about the last year or so, I moved over to the performance and scale side of engineering. So that group basically tests and vet Red Hat products like RHEL, OpenShift, JBoss, as well as partner products for scale and as well as for performance. So you'll see certain tools like TuneD come out of that group. So in the last year or so, I've been working on this performance and scale group. And by the way, you can catch me on Twitter. I'm at Sadsfay, and I have a blog at hobo.house. That is not a misprint. .house is actually a TLD. So there are some hobo related stuff there, but mostly it's technical articles and things like that. So before I get more into QUADS, or what is QUADS, who here has heard of Foreman, the provisioning? Okay, the lifecycle management tool. Awesome. I'm a really big Foreman fan, so I'm going to be making some references to Foreman throughout this talk. So before I kind of jump into what QUADS is and kind of how we've bridged some automation gaps and brought some DevOps practices to Red Hat engineering, I'm going to use a car analogy to explain what we do, because there's certainly no end of car analogies that can be used for open source or for technology. So I'm going to throw one more in there. Okay, so this is either going to work out really well and provide expert clarity, or it's going to explode in a fiery ball. So we're going to see if we can make this analogy work. So think of high performance servers as race cars, super fast race cars. And think of high-performance networks, 40 gig, 100 gig, InfiniBand, as race tracks. And the race car races that these cars run on these tracks is performance and scale testing of various pieces of software, application, full stacks, etc. Now, the drivers of these cars, I would consider kind of the pure core development folks, the performance engineers. And frankly, who doesn't like to be called a race car driver? That's kind of a illustrious, cool title to go by. And we look at ourselves, meaning myself and my other colleague on the DevOps side, as the pit crew engineers, basically. That we make all of this stuff happen. And we're kind of the enabler for massive efficiency and a lot of different workloads happening and churning out results. So following the race car analogy, there are certain track conditions. So in our case, there are lots of races happening all the time with different sets of race cars on different tracks, and our job is to schedule them as efficiently as possible. So this is where QUADS comes in. QUADS stands basically for Quick and Dirty Scheduler. So this is what kind of this talk is centered around, but it's not about why you should use QUADS or even if it's good for you to use or even ready to consume. It's more about bridging a gap with automation and with tooling to provide expert efficiency to core development teams. So let's jump into it. And this is a DevOps conference, so I think I should provide a couple slides to kind of explain the team dynamic and how we operate. So there's myself, and then there's one other colleague, and we're embedded into kind of the core development group of about 100, 120 or so engineers. And we make sure that we attend all of the meetings, all the scrums that they have that are relevant for their workflow, and that we're actually very intimately involved with their development process. Oftentimes we'll contribute code back up to their main projects, but really this is to kind of make sure that there's a very tight mesh between the development staff and more of the sysadmin operations network folks. So really it kind of becomes this gray area that we kind of do, we do both. But our focus is going to be in the automation and kind of being empowerers of the environment. So one of the things we started to do recently is we're doing team rotations where we're taking one person from the core development side and they're hopping in on our DevOps team. So they'll be helping us with automation, they'll be helping us with deployments, with contributing to the Quads project. So that's good, kind of cross-pollination. So what happens now? You have this, you've done the check boxes, you have tighter integration between development and the admin staff, but what do you do with it, right? Like, so the goal for us is to have maximum transparency within everything. So that means all the code repos are public. Public as in anyone inside the company can read them, and a lot of the code naturally goes upstream. All of the priorities that are scheduled are going to shift out and be very flexible so that, again, we're attending all of their scrums or participating in those, so we know right away if priorities change or if we can anticipate the need to write a tool to automate some process that might be a pain in the butt. And more importantly, we just really make sure that we're tightly in sync with development staff, and we look at ourselves as kind of a pit crew or a track engineer or an enabler. So these are my feel-good kind of DevOps slides. Let's get on to some pictures. All right, so what is Quads? Well, Quads is not an installer. It's not a provisioning system. It bridges several interchangeable tools together. Tools that you might already use today, like Ansible or Foreman or Puppet or Git. It bridges things together that accomplishes a certain goal that we could not find out in the open source world or in kind of common off-the-shelf products. But more importantly, it helps us automate boring manual things that we never want to do again. We kind of have the mantra that we want to build the system, we want to build a system that builds the systems. We don't want to build a system and then continually build and then continually build. So I really like architecture. I really like systems provisioning, but after the 1000th time of doing it, I really want to do something else with my time. I want to get it done, but I don't even want to know about it. Same with the networking side. Like I really like high performance switches. I like 100 gig. I like to push it as far as it can go. I like OSI layer model, layer 2, layer 3. It's all interesting, but I never again want to manually configure a VLAN on a switch. And lastly, documentation. Without documentation, you really have nothing. Something isn't finished until it's documented, but I know very few people who get generally excited about writing documentation. Yet it's one of the things that always lacks with any sort of project, and it's something that has to always be kept up to date. So when we were designing Quads, one of the things we wanted to make sure that absolutely happened was that we auto-generated as much documentation as possible. So really we could spend our time doing more important things. Cool. So what is Quads? Like what exactly does it do? It's a set of tools to automate the scheduling, management, and end-to-end provisioning of servers and networks. So frankly put, at the very base of it is a YAML file or YAML schedule for every single server in our very large kind of R&D bare metal testing environment that we do product testing. And every server has metadata associated with it, like the current schedule that machine might be participating in, or the owner of that hardware for that specific time. What this empowers is us to be able to automatically provision large swaths of hardware and networking in the future as far out as we can ascertain that there's a need for it. So just some details. How does this actually do this? So the YAML schedule, it's mostly written in Python. The YAML schedule uses the PyYAML library, which eliminates the need of human error of actually editing a text file, say, and putting it in a Git repository. We interface that with a Python CLI, which I'll show a little bit later, that you simply you enter commands, and it generates the YAML schedule and manages the YAML schedule for every asset that you have in your infrastructure. and then the automation and the provisioning works on top of that. We talked about automated documentation generation. So this is done with currently WordPress, but really anything, it'll support anything that has a Python API. So the way that Foreman fits in is that we want an authoritative source for all information for system inventory. We want one true source. So for us, that's Foreman. And then Quads will know about the scheduling metadata about all of the servers that Foreman manages. When we query those two together, we can auto-generate all of our documentation based on that. It's always correct, and it's always up to date, mostly because humans aren't involved. So how is it used today? So we at Red Hat are the biggest internal consumers of Quads. We have a scale and performance lab. So currently it's about 180 high-performance servers on 100 gig networking. And it's basically an R&D center. So a lot of the testing and vetting of our enterprise software happens here, where we might get a bug, or we might get some need for a larger customer, like Walmart or someone, that they're pushing a certain product set, like say OpenStack, beyond the bounds of what has been documented for it to work. So we're in kind of the unique position that we basically get to beat up our own software until it fails and then fix it. And then we take those results back and we pass those up to upstream. We push patches back up to the OpenStack community. And as a result, kind of everybody in this ecosystem benefits from it. But Quads is kind of the driving force behind how we efficiently schedule large swaths of machines and networks to run parallel workloads and performance and scale tests. Okay, so finally some pictures. All right. So this is a scheduling example of how we schedule things with Quads, and this is just kind of a recent one. It's not completely up to date, but what we try to aim for here is that there's no single set of machines that sits idle. That the second that a development group gets a handful of machines, say 20 or 30 servers, they have a specific VLAN requirement, all this is automated and spun up for them on a schedule. As soon as their schedule is relinquished, we really try to have it go into a completely other schedule and change hands to a completely different development group. And the reason for this is that hardware is expensive, and idle machines cost you money. Electricity cost, it has a carbon footprint, and it's generally just inefficient. So we try to squeeze the most out of this approach by having a back-to-back scheduling mechanism. So this is just kind of an illustration of some of the workloads that we've ran recently in parallel. And all of these are automatically spun up at the time that they're supposed to start, and then they're spun down again. So engineers basically rent, it's like Airbnb. They rent a set of servers for up to 4 weeks. They do whatever they want to with it, and then if they need to extend the date, they let us know ahead of time. But generally speaking, we enter it in the scheduler, we let it go, and it does its thing. Here's kind of a workload example, just to give you an idea of some of the stuff that we operate on. So this is a kind of a multi-stack workload example with OpenStack, RHEL 7.3, and Ceph. Just kind of illustrating over time, as you add more OpenStack instances, what does the result look like on block size for random reads and IOPS. Pretty nerdy stuff, but it's interesting. So, all right. So what are we solving here? What is Quads trying to fix that maybe there's not another solution out there for? Well, if you've ever managed large swaths of server hardware or hardware resources, say for development teams, there's this tendency to hug your hardware, meaning that when you set aside a bunch of servers to a group to work on something, they tend to want to hold on to it as long as possible. We call that server hugging. So, and it's generally not the best use of hardware. Sometimes they go on vacation, or maybe things just sit there and run idle. And it's very hard once you give somebody something to take it back again. So one of the goals of Quads is to kind of eliminate the server hugging. When we do this with the schedule-driven deployment mechanism, the full gamut of assignment, provisioning, deployment, and then reclamation is all done via schedule. And it's very well communicated. So development staff knows when they're going to get systems, which ones they are, how long they're going to have it, and when they have to give it back. But the reclamation happens automatically. Now, when you take something away from somebody, when you say, no, you can't hold on to this server for 3 years, which is an insane amount of time for enterprise hardware. When you take something away from somebody, you have to give something back. It's kind of a push and pull. You can't just go in there and take it. So by eliminating the server hugging, by using scheduling and scheduling things out in the future, we publish what the provisioning is going to look like in the lab as far out as we can via a couple of mechanisms I'll show you. So in an ideal world, a development group is going to know when their milestones are, when their releases come up, when they have to have code freezes and things like that. And we would know exactly what availability looks like going out. So the two schedules can kind of plan and align each other. Now, in reality, none of this ever happens. There are deadlines slip, there's bugs that are introduced, there's blockers, there's hardware issues, but that's at least we're aiming for that sort of reality. That we pre-schedule everything out as far as we can, and then we show those visuals to people. We publish a calendar that shows the availability. We show a visualization heat map that shows if there's free servers to use. That's at least the idea. Some of the other things that we solve is really just human error, is really just automation. More onerous tasks that we don't want to do, like SSHing to a switch and configuring a VLAN. Not only is it boring, but there's a lot of element of error there. You can make a typo, you can mistype a port and take down the wrong machine. There's no end of terrible things that can happen. And it's not to say that automation systems don't wreak havoc either, but generally when they go wrong in very glorious ways. So, and Dave Wilson, if you're watching this, I'm really sorry about your machines. We had some early bugs with Quads that, while it's a powerful tool, it ended up wiping out one of the developer's machines completely and giving them to someone else early. So you live and you learn, but hopefully you live. So yeah, then this falls into provisioning as well as network switch changes, which we'll get into. Another thing that we're trying to solve here is idle machines cycles. Really, it's the overall theme is efficiency here. When we have the automated spin up of machines and it's based on a schedule, we can have automated kind of weekend workloads. If we know that Susan Q, scale engineer, is not going to be using these 30 high-end servers from, say, Friday at 5 p.m. until Sunday at 6 p.m., there's absolutely no reason why we can't spin them down, have them run an automated workload, record the results, and then hand them back to her. So that's one of the kind of benefits of having everything scheduled ahead of time, outside of just efficiency savings of not having to do the thing yourself. So one of the aspects of Quads is that we power down machines when they're not in use as well. And lastly, what are we trying to achieve here? We're trying to be more, with a large amount of development resources and hardware, we're trying to be more like Airbnb and less like a hobo house. You know, the Airbnb has very strict maximum reservation times. You know exactly what you're going to get ahead of time, usually. And you really need to have a proven workload before you use it. Airbnb, maybe you need to not be a felon or have really bad reviews, and then the person will rent their house out to you. So we're trying to kind of take this approach with hardware and network provisioning. So some more pictures. I like pictures. So this is the scheduler workflow for Quads. It's not going to win any design awards. It looks like the early websites in the 90s with like the flame animated GIF under construction and like the guys with the shovels. But you get the idea here of what components sort of make it up. And at the very core of it are some Python tools that reference the PyYAML. And the PyYAML is the metadata, the key value pair metadata for every single asset in the environment. Foreman is our provisioner. Foreman does all of the heavy lifting. It goes out to the servers, it reprovisions them. If you're familiar with Foreman, there's also the concept of host parameters. So host parameters are small amounts or free-form key value pairs that you can associate with a certain server, and then you can query those and take actions against them. So we take liberal use of kind of the host parameter functionality in Foreman. But really, we're only using Foreman because that's what we happen to use. We've used it before to some extent in large production environments, and we're familiar with the tool, and we like the developer community, and I think it's a great project. But Foreman could be substituted for something else. The way QUADS is designed is it's very modular, that you can only use the pieces that are beneficial to you. Currently, right now, we're collaborating with the Massachusetts Open Cloud, which is a consortium of universities in the New England area, United States, like Boston University and Harvard. And they have a similar system called Hill, which does cloud provisioning inside of this kind of multi-university hardware setup that they have. But one of the things that their system doesn't do is it doesn't automate the documentation. It doesn't go and query the current status of the machines, what they're doing, who has them, and for how long, and then publishes this. So they're actually absorbing some components of QUADS in with Hill. They're also doing some interesting things with iSCSI provisioning over 100 gig networks, and kind of some really neat image-based deployment stuff. So it's HIL is their project. Anyway, I'm getting off track here. So this is at its simplest form, this is the QUADS architecture. There's a component called move hosts, which you can pretty much plug in any sort of post-provisioning action that you like. In our case, we have tooling that goes out to Juniper switches, and it talks to each port that each one of the servers are connected to, and it configures it with a specific VLAN design based on how we input it into the system. Right now, we support two VLAN types. We use Q and Q VLAN, so we basically support, if there's 4 interfaces on a machine, the first interface is always the provisioning interface. It always holds the public IP address. Any corresponding interfaces after that, for the default design, each interface goes into its own isolated VLAN. So if you've got 20 machines, each of those 20 machines have 4 interfaces. The last 3 interfaces, NIC 2 across all of them will be in the same VLAN, NIC 3 across all of them will be in the same VLAN, NIC 4, NIC 5, and so on. The other design is that we put all the interfaces all on the same VLAN. And it's fairly trivial to add in more VLAN design, VLAN architecture, depending on what people want. We have a request to now a feature request to implement network bonding as well. So it's getting there. It's about 8 months, 9 months old. But anyway, this is kind of the whole workflow. The host get delivered, and then we run collectd, Grafana, Nagios, and Elk, selfishly for our own interests as far as monitoring what machines are doing, monitoring the health, that sort of stuff. We don't actually run any agents on the performance and scale machines if they're running a scale or performance workload, because that could interfere with actual results you get. So in that case, to make sure that we still have monitoring coverage, we have some SNMP Nagios modules that go out and talk to the out-of-band and IP&I interfaces, and then they query the underlying hardware health. So we're able to actually do the monitoring, but we don't have to touch the actual servers to do it. And all of this is kind of included. So documentation generation. This is probably my favorite part of it. We mentioned earlier that we deploy WordPress via an Ansible playbook. It's super easy to set up. QUADS already knows about what each server is supposed to be doing and who owns it because it has associated YAML metadata. Foreman already knows about all of the other aspects of the hardware. The MAC address, the IP address, out-of-band console, all that stuff. So we take these two information inputs and we merge them together into a markdown format, and then we call the WordPress XML RPC Python API, and we automatically update the wiki page, automatically update the inventory page. And we can also generate visualizations based on this, which we'll show. Okay, so this is what would be the primary inventory system that QUADS generates and keeps up to date for you. You have your server name here on the left, you have serial number of the server, and by the way, if these R620s are actually out of support, so you're not going to get anything by getting the serial numbers, but you could pay the bill for us if you wanted to. The MAC addresses are here, the IPMI interfaces. And one thing I do want to point out here is there's 3 columns that are dynamic, completely dynamic, that query quads. The main one is workload, which we'll jump into right after this, but it drills down into what that machine is actually doing right now. Then there's owner, of who has this specific machine in this time frame. And then graph this is actually an old picture, but graph will link to Grafana graphs of per port network utilization of each one of the machines. So you would hit the graph link, and then it would bring you to a Grafana graph, and you could see over time how much bandwidth that machine is pushing out. And again, we can query that without any agents on the server, because we can directly query our switches and pull out the counters and then toss that in a Graphite and then display it in Grafana. So we kind of have metrics over time. This is drilling down more into the assignments. So when I say assignments, I'm going to also refer to them as clouds, because cloud is now a term for basically everything. So I'm going to abuse it as well. But assignments are basically predefined workloads that we set aside and associate machines with. So this is also auto-generated at a glance, and it's available to the whole development staff, anyone within the company. You can kind of see who's working on what, and what their RT ticket request is that links to this. And if you used another ticket system, you could integrate it into Quads. We used RT for this, have this integrated with IRC alerts and things like that. And instack-env is an OpenStack thing. So that's basically just, it's a JSON format that you pass to an OpenStack installer. So all you have to do is pass it, and it goes off and deploys OpenStack. So as a kind of a courtesy, and it was a feature request that was requested about a month ago, we include that by default and generate that for developers. But if you're not doing OpenStack, you just ignore it. Okay, so if you drill farther into the assignment details, you can actually see how long the assignment's been active, and you can see how long they have remaining on it. And of course, there's links to the out-of-band interface as well that development staff can hit that if they get into trouble or something breaks. And then lastly, we talked about host parameters in Foreman and leveraging these to perform certain actions on them. So if there's any broken hardware or something doesn't work right, we assign a host parameter called broken state. And if it's true, it gets pulled out of the allocation pool so it doesn't get reused. And it kind of sets it aside for hands-on folks to go into the environment and fix it. And we also have unassigned systems. This is good. Basically, we list free server pool. So there's no question of, you don't have to bribe somebody with lunch or know the right guy to know a guy to get a server to run some tests on. There's no silo there. It's clearly transparent. It's there. If there's free hardware for you to use, it's up on the wiki page, and it's updated. So we also generate some visualizations to help with the planning purposes. So when we talked earlier about, in a perfect world, development groups would already know their development schedule. And we could then schedule resources out in the future as far as we knew about. The calendar view sort of provides this month view that at any time of the month, 3 months forward, and this is configurable, you can tell exactly what's happening in the environment and who's using it. And you can kind of cross-reference this with the wiki generation that we just looked at. The last visualization, and this reminds me of the old Windows defrag program. You remember that, where it has like the little dots? Or like the Steve Gibson GRC shields up test, where it's like written in the early 90s with Perl or something. But this is like a heat map visualization that tells you per server what day of the month, what assignment or what cloud is it going to be operating in. It's stripped out for brevity, but this would expand all the way down to 300 or so servers, and it looks different when you look at the whole thing, because you can actually pick patterns. Oh, I can schedule something here. There's a big block here that helps us with our planning. I have some CLI commands here for quads. I'm not going to really go through them because they're all up on our GitHub in the documentation. The one that I want to zone in on, though, is ls schedule. So we talked about metadata per server. So each server has its own sort of metadata that's associated with it. This is an example of that. We see the current cloud, that it's actually participating in. We see the default cloud, which is where it will spin down and move to if it doesn't have a following work assignment. And then we see all of the list of past, current, and future schedules that this machine will participate in. And I'm not going to bore you with all of this. I do want to say something about this FindAvailable tool. So from an operator perspective, I spend about 50% of my time, maybe 60%, just developing quads, and about 5% actually entering the schedules into the system, and the rest of it I can spend on whatever I want. Development, writing new tools, training, whatever it works. We basically automated ourselves out of a job, which is nice, but we still have a job. So that's kind of where we wanted to be with it. But this FindAvailable tool is an interesting engineering problem, because what it does is it finds an optimal combination of servers to fit a specific assignment. You feed it the number of servers, the number of days, consecutive days you want them available, and optionally limit it to server type. When we first wrote this, coming from an operations sysadmin background, I wrote Python like I wrote shell. I brute forced everything. And that is not the right way to approach this sort of problem. So we ended up crashing our quads VM. We went back later and discovered the itertools library in Python, which does combinatorial math. That was kind of the correct way to do it, in that it runs, it doesn't crash the box, it does correct math calculations to spit out the optimal result. But it takes a long time when you have a lot of servers. So we're going to expand to about 1,000 or so servers in the next couple of months, and right now it already takes 5 minutes. So we have to go back to this again and pull in the multiprocessing library in Python and actually spin up worker threads and batch out the requests versus doing it sequentially. So it's been an awesome learning experience from an engineering perspective, because you have these data problems that you have to crunch. Lastly, we have a unified configuration file as well to try to make everything a variable. Let's see. We've already talked about all of this, what's working today. What are we working on now? So we are trying to get a nice, slick Flask web interface to Quads. We want to make it a little more modular and move to more of like a services-oriented architecture design, where we have like a server and then we have a REST API and that sort of stuff. And we're also working on automated network validation before things go out to users. And lastly, we want to move to more of a plugin architecture, so we can point it at any switch vendor and it won't matter. Currently, we support Juniper only because we only have Juniper switches. The last thing that I want you to glean from this is kind of the methodology of why we did this, and how you can hopefully take some of these ideas, back to your employer and back to some of the problems that you face, and maybe automate things and make things a little more efficient. But we wanted to have maximum efficiency in a large pool of resources. So what we're starting to see now is typically development groups will have their own budget, and the amount of budget you have is dictated by how political and how mean your manager is to fight the other managers to get more money. And there's all these little silos of development hardware everywhere. And our approach is to say, let's just put it all into one big pool, but let's manage it effectively, and let's schedule it, and let's do it in a programmatic way. So that's what we're fighting to move towards. And lastly, really just stick to the KISS principles. Just keep things as simple as possible, have a lot of little tools that do one thing really well. And that's worked for us quite well. So thank you for attending. I can take some questions now from the audience. Thank you, folks. And by the way, it's all upstream, it's all open source, it's free to use. If it melts down your data center, it's not my fault. And we've done that a few times.
Thank you for the first part of your presentation, and now we're moving to questions and answers. And do you have any of these? Everything was very clear, right?
If you want to contribute to Quads, we have everything's on Garrett and GitHub, so if you can submit patches, and we have this full regimen and CI that runs over everything, and we're super friendly, and we'd love to hear any feedback if you decide to use at least a part of it. So, any questions? No?
We have some time, so maybe you have some end notes, like 10 minutes or so.
Oh, okay, yeah. I thought you guys were making noises at me like it was time to,
We
time to
kind of
wrap it up.
expected questions, but people are very shy. Or maybe everything was very clear.
Nothing is ever totally clear. Okay, I want to get back into the commands because I think these are interesting. This is the add schedule command. This is at the crux of nothing happens without this. But you basically associate a schedule with a machine. So you associate the same schedule across a lot of machines, and then you associate those machines with an assignment or a cloud. And then when the time comes, everything spins up, the network gets reconfigured, email notifications go out, IRC notifications, ping the person if you enable that, and people get their servers. And then 7 days out, 5 days out, 3 days, and 1 day, they get emails and saying, hey, let us know if you need to extend this, but your servers are going to go away on this date. So it's kind of a compromise between constant communication, but also being very strict about scheduling and resources and efficiency. Let's see what else might be relevant.
Do I see a question? Now we have a question on my way.
Sure. It's up to you to back up your data and put it somewhere. However, we will offer permanent NFS mounts and things like that for whoever needs to back up data. But generally, it's the onus is on the person who's using the hardware to back up their test results. But we do offer infrastructure if anyone needs something storage-wise. That's a good question because in a previous demo of this, someone asked, well, you're doing servers and network. Well, what about storage performance testing? Where's the storage piece for this? And really the answer is the storage testing that we do is going to be basically on commodity hardware. It's going to be Gluster, it's going to be Ceph. The storage scenarios are actually done on the bare metal. So we have a certain class of Supermicro for these that have 36 drives each, and we have about 50 of those, and those tend to be kind of the storage class for performance and scale testing for software-defined storage. Cool. We'll check it out on GitHub. Love to hear some feedback, positive or negative. And thank you for your time and coming to the talk.